When I was growing up, my high school had the second highest drug and alcohol rate in the state. So when I went to Germany and somebody said they had 45 kilos, it kind of threw me off. I thought they might be a bit of a dealer or something, but they were just giving me their mass in kilograms. In science, like in most of the world, we don't use imperial units, we use SI units. We don't use pounds, we use kilograms. We don't use inches, we use centimeters. SI units are also called metric. To convert between units, we use dimensional analysis. It's also called unit conversion, and some teachers call it the factor label method, but don't trust those teachers. Dimensional analysis is just converting from one unit to another. It's easier to show you rather than to tell you, so let's go through some examples. How many seconds are in 3 days? For each of these, we look at our given, our conversion factor, and figure out what we're finding. Our given is the number we have, so we have 3 days. That's our given. Our conversion factor we'll get to in a second, but most people know minutes to seconds to hours to days. And what we're finding seconds. So that's what we're finding. Let me write out what it will look like. What we're going to do is a picket fence method. There's another way to do it with just fractions, and picket fence is just a way to keep track of your units. So you start with your given. So we have 3 days. So what I do is I make a line here. You can see why it's called picket fence. Now, we can't just go changing numbers willy-nilly, but we can multiply it by 1. Most people know time conversions, but you can also find conversion tables that will give you a few of the common conversions. So here when we have something equal to something else, so 1 minute is equal to 60 seconds, since these are equal, if I have a fraction with those two in there, that's like multiplying it by 1. Let me show you. So we know a day is equal to 24 hours. So 1 day, 24 hours. Okay? These two are equal, so it'd be like multiplying it by 1. But if you remember from middle school math, if something's on the numerator and the denominator, they can cancel out. So days cancels. And I'm left with hours. Hours is still not what I want, but I'm going to do 1 hour. 1 hour is equal to 60 minutes. Hours cancel out. 1 minute is equal to 60 seconds. And my minutes cancel out. So then it's just like multiplying fractions. We multiply our numerators together, and that's our new numerator. Multiply our denominators together, and that's our new denominator. All of these numbers ended up being 1, so I'm just going to multiply my numerators together.
So I have 3 multiplied by 24 multiplied by 60 multiplied by 60.
That gives me 259,200 seconds. That's my answer. I could also say this is this over 1 since my denominator is 1, but skipping the middleman here. Now, this is just multiplying fractions, so you might also see it written something like this. It's the same thing, only I multiplied fractions together instead of the picket fence method. It's the same thing, but whichever way works best for you. So here's another one. Convert 8.9 pounds into kilograms. Now, if you look at any kind of conversion table, you could figure out what the conversion rate is. Here's where I've noticed some students get tripped up. Sometimes you're given 1 kilogram is equal to 2.20462 pounds, and sometimes you're given 1 pound is equal to 0.453592 kilograms. And sometimes students mess it up. So let me go over how we're going to do this. There are 2 different ways to do it. We start with our given, 8.9 pounds. I never understood why the abbreviation for pounds is LBS, but whatever. Alright, so let's say you're given 1 kilogram is equal to 2.20462 pounds. And that's your conversion rate you're given. Since you have pounds, is what you started with, that's your numerator. You need pounds in the denominator. So I'm going to put the conversion in the denominator. And since these two are equal, so it's just like multiplying it by 1. For this one, we just put it in our calculator. We put it in, this is our numerator, this is our denominator, so we just do 8.9 divided by 2.20462. That gives us 4.0369 blah blah blah. By the way, these canceled. kilograms. Now, 8.9 is a measurement, so it has 2 significant digits, and our final answer will be 4.0 kilograms. Okay? What if we were given this conversion instead? Well, we still start with 8.9 pounds. And pounds still has to be in our denominator. So 1 pound is equal to 0.453592 kilograms. So this time we multiply 8.9 multiplied by
0.453592.
gives us 4.0369 blah 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 blah. Or significant digits again, 4.0 kilograms. We ended up with the same answer. No matter what conversion factor we're given, we get to the same answer. Something that students get mixed up on is they look for where to put the 1 instead of where to put the unit. See, you have pounds up here. To cancel, it has to be down here. It has to be, if it's in the numerator, it has to be in the denominator. If it was up here, it has to be down here. So make sure your units are right. Always watch your units. They're tricky. If your units are right, you'll be able to put your other numbers in the right spot. So always make sure that your units are opposite. If you put pounds times pounds, you get pounds squared, and that's silly. Another place I see students getting confused is when they have to do speed or velocity. Because we have miles per hour and we're going to meters per second. Now, we're changing 2 different units here. So how do we do that? We use the picket fence method again. So we have 48 miles over 1 hour. Let's make this nice and big. All right, I'm going to start with miles. I have a conversion table here, and I see that a kilometer is equal to 0.6213 blah 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 miles. So I'm going to put that in there. Now remember, miles are up here, so my miles have to be down here. So miles is
0.621371 miles
is equal to 1 kilometer. Miles cancel out. Well, this is great. Now I have kilometers per hour, which is good, but not where I want to go. Now, kilo means 1,000, so I need to get it to meters. So since kilo means 1,000, that means there are 1,000 meters in a kilometer. So kilometer needs to be down here. 1 kilometer is equal to 1,000 meters. Okay? So kilometers cancels, and now I have meters per hour, which is a lot better, but we're still not there yet. Here, hour is in the bottom, so hour needs to be in the top over here. Remember, for them to cancel, they have to be on opposite sides of that dividing line. So I'm going to do 1 hour. Now I can convert hours to minutes or minutes to seconds, but I'm also super lazy, and I know there are 60 minutes in an hour and 60 seconds in a minute, so there are 3,600 seconds in an hour. So I'm just going to do that. Now hours cancels because I have 1 at the bottom, 1 at the top. Now I have meters per second. So I'm going to multiply my numerators. So I have 48 times 1 times 1,000 times 1. Obviously I don't need to put in the ones, so 48 times 1,000. You could probably do that in your head. So here I have 48,000, and my denominator is 1 times my conversion factor times 1 times 3,600. So then I get 2,236. And I divide those. And I get 21.4. Or remember significant digits. So I have 48 miles per hour, so my final answer should have 2 significant digits. So my final answer is going to be 21 meters per second. Dimensional analysis is used a lot in both chemistry and physics. Sometimes you're given pre-existing data and you have to convert it for it to work in certain equations. Dimensional analysis is one of those things that gets easier the more you do it. So the more you practice, the easier it'll get. So just keep practicing doing lots of different kinds of problems. It will come easy to you after a while. In science, the SI method.